Yeah, hello, students. This is lesson number 2.2, Maths 142. So the learning target is here it is define a sample space for a random experiment, identify events for a random experiment, and how to compute theoretical and experimental probabilities for an event, and also compute probabilities for events with equal likely outcomes. So let me walk through this before we go for a probability. Before even we start the actual example, I want you to understand what is the meaning of sample space. So this vocabulary word is very important, and it all depends on a situation. So I'm going to give you example of what is that meaning of that sample space, so that we can also understand, then identify the ra- events for a random, and also what is this piece. So when you look for these two pieces, it could be, let's imagine a simple example of a coin. Now, a coin has a head and a tail. So it has a head and a tail. So when you toss a coin, either you're going to end up getting a head or a tail. So we assume that the head has to be showing up with the head. So this is the thing. Maybe head is front and the tail is at the back. So what does uh, sample space basically means? Tossing a coin. What are the possibilities? What are the options you have? When you toss a coin, you end up getting, either you may get a head or you may get a tail. So this is called sample space, and we put a braces here. Look at this. This braces I use, and this is written as uppercase sample space S. So whenever one coin is tossed, so you have this sample space. Now identify, then what is the meaning of identify? What is the meaning of event? Suppose this is sample space. Suppose I call an event maybe E. Let's call event head shows up. So that means head shows up. So this means that the event here is, it is the subset of the subset. What is subset means? All anything from this sample space. So even though you have head and a tail, so the event here is head. So head shows up, and that's what that basically means. What is the meaning of that E? And I'm coming to straight away then. What is the meaning of probability? So suppose I say, what is the probability of head showing up? So if I'm going to write this in word, head showing up. So the probability of head showing up basically means what are the chances that when you toss us, so the shortcut is P, and we can call that event as the event is the head shows up. So we use this symbolic way saying, hey, what are the chances that when you toss a coin, you end up getting a uh, probability of E. E means the event, and what does event? Head showing up. So that means the chances that the head showing up, and this probability is always a ratio. That means you have from all. Now, when you write this, so there are number of. So what is the meaning of n of parenthesis s? It means a number of possibilities. Or we don't say possibility. We say number of outcomes. This is the word used when you toss a coin, the number of outcomes here is there are two of them, so H and T. So when you talk about probability, it's always the number of the total sample space, that means how many are there in the, and then the numerator is the number of n of event, means it is the number of whatever a head showing up. There is only one. See, this is the only one. There's only one head showing up. So I will write this as one out of the this is 2, so that's why it is half. So you can clearly see this is, and it is less than 1, right? So the probability of the event that when you toss a coin, you get a head is 1 out of 2. So because there are two options, two outcomes, and from this you have head. So this is the meaning of so let me take another one so that you can get an idea what I'm talking about. See, Instead of one coin tossing, let's say there are two coins. So these are the two coins. Now, when you toss two coins together, so what are your outcomes? So, so that means we want to know what is that sample space, and the sample space in this example would be. So maybe I'm using braces to write that. This is the S. So maybe the first one is the head and the second one is also the head. So that means first one is head and second one is the head. Or it could be the first one is the head and the second one is the tail. So this is another, we also call this as, what is it called? Events, a single event it is called, means it could be head and a tail, or it could be tail and a head. So these are outcomes with tail and head. Each of them is called simple events also. Simple events means a single line. And also it could have been tail and the tail. So you can see clearly the visuals are very clear. These are, so how many number of outcomes are there in sample space? And you can see there are one, two, three, and four samples. Now we can, uh, knowing this, we can have a lot of options here, and the option that I can think of, maybe I can think of an event A. Let's call A is uh, both 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 are heads. See, so this is an event where both are heads. That means first one also is head, second other. So what is the chances this can happen? So what are the probability that event A will occur? And you can see the ratio. It is the ratio of the total number of outcomes are four. So this is that total outcome means the sample space, and the number of outcomes that satisfies this, so that are favorable to this description that both are hits, and that is the A. And you can see there's only one option in this example, that this is the only option you have. So there's a, so in this example, the number of, so the n of A, it means how many outcomes are favoring both heads, and you can, there's only one outcome. So that means it is one out of four, and you're done. That's the understanding of this A. I can just create another event B, saying that uh, uh, both both head and tail shows up. Means, so what does that basically means is, that means I can write this sample space as both head and tail. It means the first one could be head, the second one is the tail, or the first one is the tail. So both of these simple events, can you see this? These are called simple events, and both of them had head and tail also. That's why we say here in this example, the number of both heads will be, there are two options. See? So if I want to write the probability of this, probability of B basically means both head and tail, and you can see there are two options, two outcomes, two out of four. So it's always out of four. So if I can have another example of probability. So a lot of examples you can think of. Uh, if I write probability C, an event where maybe at least, so I can write at least one head. So what is the meaning of? Let's understand this. At least one head. Now, what does that basically means? It means, this means the sample space would be, uh, at least one head means either both are heads, okay, or at least one head. It means head and tail, or the tail and head. So in each of these pieces that you see here is that in all three cases you see there is at least one head. So even though this one has one head, this one also one head, but this one has two head. But the description is being fulfilled. It really allows you to write these three pieces. So if I want to write what is the probability of uh, that this at least one head will be, there are four, that means n of C divided by n of S. So the answer becomes, there are three of them. You can see these are three out of four. So this is how questions can be asked. Now let's talk about what if the same thing was clear this. This is very important before I show you the we go to all the before I go and work on the problem. Let's take three coins and then I'll go to a few more examples to understand. Suppose there are three coins, like you see. So we have three coins here. So what is the sample space? And you can see sample space could be head, head, and head, all head showing. So one option will be all head showing up. What is the other option? The first one is the head, second one also the head, the next one is tail. So I think you understood what I'm talking about. Head, and tail. Or it could be head, tail, and head. See? So this also could be another outcome, head, tail, head. Or it could be head, tail, and tail. So that means it is head, tail, and tail. Or the first one could have been tail, and the next one is both heads like this. See? So it is tail, head, head. Or first one is tail, and the second one is head, and the third one is tail. So head, head. Sorry, I made a mistake here. So it is tail is first. So it is tail, tail, and head. Or it could be tail, tail, and head. So tail, tail, and head. And the last one will be tail, tail, tail. All shows tail, tail, tail. So now we have three like this, right? So this is sample. So what is the number of outcomes in the sample space? And you can see there are 1, 2, 3, 4, 5, 6, 7, 8. So this is 8. Now we can create a sample, an event and saying, okay, an event A that's uh, uh, two tails maybe. Let's see, two tails. So out of this, when you toss three coins together, and it says three tails. Sorry, not three tails. Let's see two tails. So three tails. Okay. So not three, two tails. Sorry. Wow, that means I have to look up for which are two tails, and you can see this one has three heads. This one has two heads. This one has two heads. Oh, there it is, two tails. So this is the one. So one of this. Then also two tails. You can see this is the one. And you can see there's another one here. So there are three. So that means n number of outcomes that has two tails is three. And we want to find what are the probability that event A occurs. That means probability of two tails showing up will be the total is all the sample space, and this is how many outcomes favoring the two tails. And you can see that this becomes 3 out of 8, and you're done. So this could have been one, or we could create another sample space B, and in this case we can see, let's see, all heads. Now, what does that basically means? And you can see in the example there. So, how many out of those eight options, how many have all heads? And let me put this. And you can see this is the one that has. So that's the only one that has all heads. So the number of outcomes with all heads is just one. So that means we want to know probability that this occurs. So probability of all heads would be number of outcomes for this divided by all of them. All of them are 8 always, and this is 1, and you are done. So this is again, so probability is always less than 1, and or it could be 1 also. Let's see, another option is probably, let's just see, let's see, at least two heads. Let's see, this one I said two tails, right? Suppose I say at least, at least two heads. Now, what is the difference between this and this? This is all heads. Now, this basically means at least two heads. It means it could be that two heads or three heads. What does this means is, uh, oh God, I'm so sorry. So let me put C is an event that uh, at least two tails. Let's put it like two tails then. That means what does this means? It is two tails or three tails, all tails. This is what. Now at least two tails. So then let's write the all the outcomes for this. So at least two tails will be. You can see here two tails. There it is. You can see this. There are two tails right here, and there are two tails right here, and there are two. So there are three here. But then there also we have to include three tails. So this also. So there are four options here. So n of c. So let's write. So it is the head, tail, tail. Then it is tail, head, tail. And there is tail, tail, head. And it is tail, tail, tail. So these are the four pieces. So the probability that at least two heads or two heads, maybe I think, yeah, two tails is probability of C is the number of outcomes, all possible outcomes, which is the sample space and number of outcomes that are favoring the event C. And in this case, you can see this is four here. So this has, there are four of them. So four out of eight, and then we can reduce to uh, half. Okay. So these are a few examples to understand. So I'll take another example of. So I gave you an example of about coins, right? So this was done. Now let's take an example of a dice. So now what is a dice? So the dice is always a cuboid, a cube with six faces, and each of the faces are numbered, and the numbered are 1, 2, 3, 4, 5, 6, right? So the front and the back. So the front and the back, uh, so one, the back side will be 5. So maybe this one is 3. So the other one may be 2. And we have down one. So the down one may be 4. The top one is 6. So these are all. So the question is when you roll the die, they always use the word roll a die. So what shows up on top? Okay, so what is that shows up here? So this is the thing what we need to know. So now what are our outcomes? What are the possibilities? Assuming that this is called a random, this is called random uh, experiment. Okay. So if I do this random experiment of so there are two things we are going to learn also is one thing called when you do this random experiment there is something called uh, theoretical probability. What is theoretical probability is something to do with reasoning. We use our common sense, like we use like a theory type. Theoretically, we can reason out saying that, hey, since there are six of them, so we say, if you go on rolling this die for some number of times, uh, let's see, let me take that example later on because I just wanted to show here. My goal here was to show what is the meaning of, okay, what are the sample space? So actually we are talking about common sense reasoning. So what are our options when you roll a die? It could be 1, it could be 2, it could be 3, it could be 4, it could be 5, and it could be 6. So when you roll ones, then these are the options you have. Simple events they are called, and that means the number of sample space. This is the sample space is in this case. Sample space is 6. So there are 6 of them, right? Now, question is we can create A as so we can create some an event saying that, okay, uh, an even number shows up, an even number shows up. So what is that basically means? Even numbers are, so you have option 2, 4, and 6. These are the even numbers. And you can see the number of outcomes here are 3. And then if I want to notice the probability that the the even number shows up it is 3. So n of A divided by n of 6. N of S, which is 3 out of 6. So it means out of 6, there are 3 of them, and you end up getting half because if you divide by 2 or 3, both of them, you get half. So this is uh, one example of probability of getting an even number. So, so again, I'm writing. Let's take another few examples just to get an idea what I'm talking about. So this is the sample space, right? When you roll a dice, right? So B, let's take another example. B, number greater than 4. Number, sorry, number greater greater than 4. Now, number greater than 4 means, so the number of favorable outcomes for this will be, so the 5 is a number which is greater than 4, and 6 is the, so there are two options for this. So you have two options here. So if I want to know what are the chances that when you roll this, when you roll a die, what are the chances that you're going to end up getting a number which is bigger than 4? And the answer is we have to use number of outcomes for B and number of sample space, and that is 2 out of 6. And if you divide by 1/3, divide by 2, both up, down, you get 1/3. So this is what the understanding of probability is. And as you move on, we'll also suppose they could have said what is the probability of getting a composite number. See that they could say, hey, what is the uh, composite number? So the question is, what is composite number? So the composite numbers are one is not composite, one is neither composite nor prime. So two is a prime number. And what is the meaning of prime number? Basically means a number that, so 2 and 3, uh, 3 and 5, these numbers are called prime because they can be divided by exactly two numbers. One, so 1 and itself. So that's how it is. But what is composite number? Like 4 and 6. So why 4 and 6 are composite number? Is because 4 is divisible by 4. 4, there are three divisors here, 1, 2, and 4, right? And for 6 also, there are three divisors. There are four of them, 1, 2, 3, and 6. So more than 2. So that's why these are composite numbers. So what is the probability that this event will occur is, so it will be out of 6. There are 2 again here, 2. So it is 1/3. Okay, let's say if you have, sometimes they roll two dice. Let's see, if you roll two dice, what are our options? So rolling two dice, then you'll have to have like a ordered pair. So that means we want to know what is this one, what shows here, what shows here. So that means it could be 1, 1. So there are a lot of options here. So the sample space could be, so the first one is 1. For the first one is 1, and the second one is 1. See? Or the first one is 1, the second one is 2. The first one is 1, and I think, so like this you can get. And you already know what I'm doing. So it's just like just figuring out like this. Or it could be the first one is, so it could be the first one is showing 2, and the second one shows up 1, or 2, 2, or 2, 3, or it is 2, 4, 2, 5. I like to show this so that you get a total understanding. Or it could be the first one. The first one here is 3. Suppose this was 3, and the next one could be 1, like this. See? Okay, hope you understand everything. We get all this. I think somewhere I wrote, oh, this is 3, this is 4, this is 5, this is, or it could be 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. Or it could be 5, 1, 5, 2, 5, 3, 5, 4. You can fast forward now. You know already what I'm doing, right? Once you know, you don't have to. You can fast this. So it could be 6 and 1, 6, 2. And clearly see, you can count them. Do you even have to count them, or it is 36, right? So the number of sample space here is 36, and that's because of it is like 6 here. Can you see this for? So the first one could be any of the 6, right? So this could have been any of the 6. And the second one also could be any of the 6. So the total, so by fundamental counting principle, so the total number would be 6 times 6. See? The visuals help you to clearly see what's going on there because they can give you a question is, hey, what are the probability that the sum of, so we can have a event where the sum is 5. See, so which are the options we have here? So which are the option you have 5 is, okay, the first one is 1 and 4. This could be, if it is 1 and 4, by default it will be 4 and 1 also. What is the other one you can think of? 2 and 3 add up to 5, and 3 and 2 also add up to 5. So you have 4 options here. And that's why probability that the sum is, they add up to 5 is there are 4 of them, 1, 2, 3, and 4. So 4 out of 36, which could be reduced to uh, 1 out of 9. Okay, and you're done. But sometimes they ask you to write in the, you have to use a calculator and write down 0 point, maybe 1, and blah, blah, 2 places. So I hope I made sense to you. So they can ask a lot of questions like this sum is 5, 6, 7, 8, 9, 10, like that. Or they could ask all instead of saying some, or they can say both both first and the second die shows up the same number, and then you'll be seeing this. Oh, it could be 1 1 2 2 3 3 4 4 and 5 5 and 6. So that means if B is the event that both faces are both shows up the same number, then it will be 6 out of 36. So easy it is. But symbolical, we write n of b divided by n of s. So like that, we can create a lot of question. And if the question was asked, what are the chances that when you roll two dice, okay, one dice, two die, what are the probability that sum is 13? And you can see, are there any of these out of 30? You should see all this 36. Do you think anything add up to 13? So there's not a single one because the maximum you can have is 6 plus 6 is 12. So you cannot have 13. So in such case, we say if C is an event, sum is 13, then the number of this is 0. There's nothing. So we say, okay, probability for this is, so such cases we say probability that sum is 13 is n of whatever that may be. C is sum is 13, so we can write n of C divided by n of S, and that becomes 0 over 36, which is 0. So 0. So your probability, when you talk about small p stands for probability, is you can have a 0, and also you can have at the most 1. So your maximum is probability is 1, and the minimum probability is 0. Let's see one more example. This is about the dice. And last one I can take is one more example I'm going to take is deck of cards. We have a lot of question on deck of cards. That means deck of card can has so the card can there are 52 cards here. There are 52 cards, and we these 52 cards have uh, four suits, and the suits are they break into 13, 13, 13, 13. So 13, 13, 13, and 13. And maybe diamond is the, so we have diamond, see, or it could be heart, two red cards. So these are also the red cards. There are 26, 13 plus 10. And the black cards are maybe you have spades. This is a spade or a club. Okay. So these are 26 black cards. These are 26 red cards. And each of these cards, let's say diamond. Suppose I'm talking about a diamond itself has got one ace. Okay. So one first card is the ace card, or it could be 2, 3, 4, 5, 6, 7, 8, 9, 10. The next card is called jack, and then the queen, and then the king. So this is how it is. So if the question is asked how many queens are there, and you can see each of these suites have one queen. So in the red there will be one, and here there will be another hearts of uh, queen, or you can have a queen of spades or a queen of clubs. So like that, we can have four each, right? So all these are like there are four aces. The whole deck of cards has got four. Each one of them there are four like this. See? So this is another thing you need to know. And then one more thing you have to know is what is the meaning of face card. So what is a face card? So the face cards are the four jacks and the four queens and the four kings. Okay, so these are the face cards. So let's go down directly to what I mean to the problem to the actual lesson. Okay, we'll go down. Whatever I explain is right here. So the first page that you see on your packet is. Yeah, so I hope you guys understood what is the definition of. So when you talk about relative frequency, it's basically means the sample space, all possible outcomes, and n of let's see event e. So that's what a ratio. This ratio itself is called relative frequency of the of that outcome. So it's the ratio of the number of outcomes favoring the event divided by the all possible outcomes. Okay, let's take directly an example if you get confused. And the first, okay, here it is. I want you to before if you see there is a theoretical probability and empirical probability. Let's take an example and then we go back there. So if you take this, let's see this example. So what does it say is so what does this say is that a die. This is so this is example number one. Uh, if a die is rolled, now this is a die is rolled how many times? And it says a fair six-sided die. So what is the meaning of fair? Basically means it's not heavy on ones. It's like each of these numbers that shows out is equally likely. Okay, so there is no what is that called weight on one number, but any of this number could. So it is like a random experiment. Anything is possible out of it. So These are the numbers that shows up, and it is rolled 100 times. This is very important. And you can see when the table shows you two columns. The first column shows a die outcome, which is could be 1, 2, 3, 4, 5, 6. And the second column shows you how many number of times out of 100. So the total is number of times the so this is 100. So from 100 out of this is a frequency basically means how many times. So if what does this means is the number one shows up 21, number two showed up 14 times, like that. So the question is, first question is asking, what is based on the table, what is the probability of rolling a die, rolling a 5? Now, this is called, now we are, what is that called? Empirical. This is what I'm on. Empirical, em, empirical probability is hands-on activity. This is called hands-on activity. So you actually try to roll the die 100 times and seen the data, and the data shows that, and the question is when you do this, this is that sample space n of s, okay, 100 times. So and then what do you realize is you want to know what is the probability. Let's say the 5 shows us. So the event is from the table that 5 shows up. Okay, and you can see 5 shows up here 24 times. The probability of is the number of times that 5 showed up divided by the whole sample space, n of s. So that means there are 24 divided by 100. And when you do this, what does this basically means? It is 24%. Okay? Or you can write it also, probabilities has to be between 0 and 1, so it is 0.24. So this also is correct. This also is correct. I'm going to show you, this is for every 100, there are 24 number of times the 5 shows up. And this is called empirical probability. With this empirical probability, what is the theoretical? So we want to know what is the meaning of theoret. Here it is. If we were to roll 10,000 times straight, what do we expect the ratio of the 5 to be close to? So theoretical basically means is by reasoning. So by reasoning, we know when this dice is rolled, the common sense is what theoretical probabilities. So that means when you roll a die, you know there are 6 possibilities are there. So that means it is always 6. 6 is the denominator, and the 5 will be, let's see, if this is 5, and in the sample space 1, 2, 3, 4, 5, 6, there is only one 5. So there is only one 5. So this is the probability. Now, if you take this one, if you take the um, if you take the ratio of this, you end up getting 0.0.16 and some number. In other words, this is like 16%, almost close to 16%. So this is the theoretical probability. So what does this say is if you go on repeating this 1,000 number of times, this empirical probability, instead of 24%, this will almost end up getting equal to the empirical probability. So that's the meaning of empirical and theoretical. Where theoretical is we use our common sense and say use the reasoning and say okay 16%, but actually it is 24%. But if you do it 100 times, but the more you do, like 1,000 times, maybe 5,000 times, and maybe 10,000, it's really seen, huh? This is really done, and they have seen that this number 16% almost end up getting to, sorry, this 24% that you get here, that 24% is almost becomes equal to 16%. So that's the understanding of theoretical thing is it says So, so there are six side on the five, and the five side is just one of the six. So that would mean our theoretical property would be that, which I already showed. This is theoretical probability, and this is, I'm still trying to show guys to you to understand that this is hands-on activity, which is empirical probability. So let's go to the directly to the definition there, which says here it is. You go, you can see. So here, theoretical probability. Oh, I'm empirical is EMPRICL. Okay. Empirical probability. I think earlier I wrote it wrong. So the expected ratio of an event occurring based on the mathematical calculation or logical reasoning. It is determined by analyzing possible outcomes of a situation without conducting it. This is without conducting. Remember when you roll the dice, we use our common sense saying that mathematical, the sample space is 1, 2, 3, 4, 5, 6. And that's why we say, so the probability of any situation, right, it's always out of 6. And the situation is maybe 2 shows up, so it is 1 out of 6. If it is 2 shows up, or probability of 3 shows up, then it is 1 out of 6. So this is always almost like 0.16, which is like 16%. Now, what is the meaning of empirical? Basically, it's a ratio or relative frequency of of an event occurring based on actual experiment, hands-on activity, or calculated data. It is calculated by dividing the number of times an event occurs by the total number of trials. So the one that we did out of 100, remember it was 24. That's the empirical probability. But the empirical probability is going to be almost this only when you do increase the number of times the experiment. And I hope that helps. Let's go directly to the problem. Okay. So now I think now I should accelerate because you already got the fundamentals what I'm talking about. Look at the example number 2 is construct a sample space for the experiment. It consists of tossing a single coin and observing which side is facing up when it lands. Yeah. Did we not do this? Yes. It's when you toss a coin, this is the head this side and the back side will be the tail. So the sample space, and I always use this, is going to be either the head or the tail. So that's it. You're done. That's all they're asking you. Let's go to the next question. Example number 3 says, so example number 3 is construct a sample space for the experiment consists of rolling a single die. So this is what I've been showing all the time. So this is what shows up. Find the events. So there are two of them. The first one says an even. So let's see. A is even number. Even number is rolled. Means even number shows up. Now for this, the favorable outcome could be 2, 4, 6. These are the only one, right? And the sample space is all 1, 2, 3, 4, 5, and 6. So these are all possibilities to show here on top, right? But the one that is favoring is 2, 4, and 6. So the probability that the question is asked, oh, he's not asking the event. The event is only which one? So that's it. This is the answer. But I'm going a little further down to show probability of this event is the number of outcomes for that event and the number of total outcomes in the whole sample space. So in this case, there are 3 here. And you can see there are 3 of them, 2, 4, 6. So 3 out of 6, which is 1/2. And you're done. And the second one says the number greater than 2. Now this one number greater than 2. So whatever this shows up should be greater than 2. So this sign means bigger than 2. That's all it means. Now the numbers which are bigger than 2 are 3, 4, 5, 6. So if I write B is an event that greater than greater than 2. So that means B has favorable outcomes to be 3, 4, 5, and 6. So these are the numbers which are greater than B. So there are four options. Now, if the probability was asked, what is the probability that the number is bigger, then you have to have a ratio. That means number of all possible, and the number of favoring. Here you can see the number of outcomes favoring this is 1, 2, 3, and 4. So that's that n of b. So the answer is 4 out of 6, which you can reduce by dividing by 2 and you get 2/3. You're done. Now, this one says construct a sample space that describes three child families according to the binary genders of children with respect to the birth order. For simplicity, we are only using the binary gender. So it's not like a person is both male and female. No, it will be either male, either boy or the either it is the boy, we'll call it B, or the girl. So three child family will be, that means we can say these are the options. See, the first one, second one, and the third one. The first child. So this is the first child. This is the second child. This is the third child. So what are the all recognize there are okay? What is the construct sample space? So that means you can have all the boys, 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 and boys. See, or it could be boy, boy, and a girl. It could be boy, girl, and a boy. Or it could be boy, girl, and girl. See, all different ways you can do like this. Or it could be another four of them. So another four could be first one is girl, and the second one could be boy and boy, girl, or it could be boy and girl, or it could be girl, girl and boy, or it could be girl, could be boy, boy. That's it. See, there are 1, 2, 3, 4, 5, 6. So this is the sample space. So almost like that, the one I was talking about, I think there was one example I did head and tail when three coins were tossed. So almost the same idea. Another way to do is using tree diagram. It means you can say, okay, if the first is boy, then the next one could be boy and girl, and the next one could be again boy and girl. See, if this one is girl, then you have more option boy and girl. Like, okay? So you have four of the, or if the starting is a girl, then the next second one could be boy or girl. If the second one is boy, you have third one will be boy and girl like this. And if the second one is girl, this could be boy and girl. And you can see the all the three, 1, 2, 3, 4, 5, 6, 7, and 8. So it's the same thing here, which is the. I hope I made sense to you. So example number 4.2, a random experiment consists of tossing two coins. Write down the sample space. We can tell the difference between the two coins. What outcomes make up the even there is at least one. I think I already did this. So when you have this, so the sample space is head head, head tail, tail head, and these are four options. Among these, it says at least one means you can have either. What does this means? Either you have one head or you can have both heads, both are or both heads. And you can see from this example that at least one head is see. This one has one head, this one has one head, and this one has both heads. So all these three. So when they ask you an event means subset. So the vocabulary word is called subset. That means out of this four, you have an event which says at at least. So at least one head. So it means your answers are there are three head, 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 tail, and tail head. So that's what the question is. What outcomes make up the event? So these are the outcomes which make up the event. But if the probability was asked, what's the probability of that event occurring? And it is all sample space, all the outcome in the sample space and all the outcomes in the event. That is 3 out of 4. We are done. So this is little theory here to understand the concept, understand what is a probability. It's a numerical measure. Likelihood of an event occurring expressed in the number between 0 and 1. So that's what the probability is always from this, or percentage. So it means what is percentage? Basically, if you have 0.3578, so what this means, we can write it as 35.78%. You move the decimal 2 places. Now, probability of an outcome. Now, this is what I've been already explained to you. When we perform an experiment, each possible result is the outcome, and that's what I've been always saying. E is an outcome. We denote the probability of E is PE. Uh, that means when I talk about a dice, maybe each one of them is an outcome. See, 1, 2, 3, 4, 5. This is a sample space, but each one of them is an outcome. So these E. So these are like E1, E2, E3. So these are separated. Each one of them called an outcome. And the probability PE. So when you talk about probability of E1, basically means you're asking probability one shows up. So it's good to understand the theory also. So probability of E means chances that the number one shows up between 0 and tells us how likely that outcome is to happen in a single trial. That means when you roll a dice, so that's called when you do the experiment, single trial of an experiment when you roll a die. And outcome basically means what shows up here. If the probability is 0, we say it is impossible, and if the probability is 1, the outcome is sure to happen. Now, probability of an event, because when I say probability of event, there will be many outcomes. When I say here, if I say what is the probability of getting a number greater than 2? So it is 4, 5, 6, and so the answer is each one of them actually. Even though we know that it is 4 out of 6. But what does this basically means? Probability of getting a number greater than, let's see, E is greater than 3. Sorry, greater than, let's put it like, okay, let's put it, 3. Greater than 3 will be, it is probability of 4 plus probability of 5 plus probability of 6, like that. Oh, no, 7. Sorry, this is 3. I think I'm doing it fast. 3. That means it is 1 out of 6 plus 1 out of 6 plus 1 out of 6, and that is 3 out of 6. Okay, and this is how what this means actually is that. So, anyways, I think I messed up here. I wanted to give an example of, let's see, 2 here, because that greater than 2 would be more better to understand. So, what I'm saying is, if I say probability of greater than 2, and the numbers that which are bigger than 2 are 3, 4, 5, and 6. See, these are the numbers. There are 4 of them. So when I talk about probability of greater than 2, basically it is probability of 3, then 4, plus probability of 5, each one of them probability of 6. That's why this word E1, E2, E3 basically means this is that E1, E2, E3, and E4. So instead of doing all this, we write directly probability of event E, which means number greater than, and there are 4 of them, so it is 4 out of 6. Of course, you can reduce it to 2/3 also. So look at this example number 5. Everything I already did in the first 30 minutes, so it's the same. The coin is called balance or fair if each side is equally likely to. So if this is head and the back side is tail, So equally likely basically means it's not biased. Okay, it can either head or tail. Assign a probability to each outcome in the sample space for the experiment that consists of tossing a single fair coin. So what is asking is each outcome. So when you toss a coin, you have sample space head and tail. So, so this is the sample space, and the probability that it is a head shows up. Let me write that the event is head shows up, and this answer means there is only one head. So it is like saying, okay, an event A is head shows up. I think I'm writing this so many times. It's like number of outcomes that head shows up, which is the A, and all the outcomes in the sample space. So you can see there's only one. Here's one out of, and here there are two. And that means number of outcomes in the sample space is two. So one out of two, and you're done. And the same thing we can do here also. Probability that tail shows up. So again, you have only one tail here. So this becomes one out of two. You're done. Example number 6 says the die is balanced. Oh, this is now this also I explained. Die is balanced if each each side is equally likely to land on top. It means on this one. Assign a probability to each outcome in the sample for the experiment consists of tossing a single die. And then in this case, what is the It's like probability of one shows up. Okay, what does that means? That means there are six. Of course, the sample space you have one, two, three, four, five, six. So these are all options for the sample space. There are six of them. These are six. So out of six, one shows up means one. If I say probability of two shows up, that's the event. Uh, it will be again one out of. If probability of three shows up, so like that. So now let's go directly. The question is an even number. So even is 246. Okay, and the probability is probability that this occurs is that the total number is outcome is 6, and from 6, the one that are even are 2, 4, and 6. I think I missed a 5 there. So there's a 5 missing here, right? So there is 3 out of 6, which is 1 over 2, which is 0.5, which is also 50% probability. And the next one is the number greater than 2, which I already did. So T is greater than 2 will be 3, 4, 5, and 6. So you can see there are 1, 2, 3, and 4. So probability that the number is greater than 2 shows up is there are 4 on top and out of 6, which is 2/3. And if you see, this is like almost like 0.6666 like this, which is 66.66%. Let's go to the next. And these are the simple example you did in even in the fifth, sixth grade. There's a bag, and in the bag there are 20 cherries. That means these are cherries 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So these are 20 cherries. These are 20 cherries. And there are, oh, sorry, it has 20 cherries. But among this, I'm sorry. So in the bag, if this is the bag, this bag contains 20 totals altogether at n of s. Any one of them when you pull out is 20. And among these there are 14 sweet. So let's sweet means let's put like pink color. So 14 sweet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. These are 14 sweet cherries, and there are 6 which are sour black. So these are maybe these are 6 and these are 14. And you pull out one of these from the, if you pick a cherry at random, what is the probability that it will be sweet? So your event is when you pick one of the fruit there that is going to be a sweet. So that means probability of that is going to be sweet is the number, the whole sample space and the number favoring the sweet. And the number favoring the sweet is the pink color. See? So this is 6 because there are, sorry, this is 14 and the total number is altogether 20. See? That's it. Because these are 20 of them. Oh, here it is. And we can reduce this to by 7 over 10 by dividing by 2. You get 7 over 10, which is 0.7. Okay. Or you want to multiply 10 and divide by 10, you get 70 over 100, which is also 70%. You're done. Oh, a standard deck of cards consists of four suits. Remember hearts, spades, and these two are red and these two are black. Okay. Now spades, okay, here they already gave you diamonds are red. Each suit contains 13. I already explained this. Each different rank and ace, which is in many games a function as both low card and the high card. Cards 2 through 10. So there's a ace card, then the number card is 2 to 10, and a jack, queen, and queen. So the question is, since we already know this, what is the probability that when you draw a deck one card? So if this is the deck of card, so if this is the deck of card here, these are all cards. You pick one of them. What is the probability that this will have when you pick up when you pick you get a getting an ace. So what is the probability of getting an ace? So the first question is how many cards are there? So it means the number sample space, right? And this is the number of let's see if this is the one I can call it as A. So it's like A. It means getting an ace. So how many ace cards are there? So the ace cards are four. Okay. So heart of ace, diamond of ace, club, and the club. All four of them means from 52 cards. You're done. You can if you divide by these four and four here, you get 1 out of 13. And you're done. That's all the question is. The next question is what is the probability that when you pick a card and getting a diamond? So how many diamonds are there? These are diamonds which are red ones and there are 13 of them. The probability of getting a diamond is altogether the total number of cards are 52, so it's always going to be 52 at the bottom. Another way is another way to say is actually it is 50. When you say 52 means basically from 52 cards you pick one card, so that's the same thing as 52. What are the chances that you're going to get a diamond? So that means diamond, there are how many diamonds are there? And you can see these are 13 diamonds, so it is 13 out of 52, right? Which is going to be 1 out of 13 also. I think I made 13, 1 out of 4. Sorry, this is 1. If I divide by 13 and 13, you get 1 out of 4, which is 0.0.25, I guess, which is 25%. And that's it. Next is what is the probability of getting one card from one card and getting a black card. So what does that means? Probability of black card. It is 52 total number of cards, and there are how many black cards are there? And you can see there are the the club, the spades, okay, the spade, and these two cards are black cards. So there are 13 and 13, 26. So 26 out of 52. And if I divide by 26 and 26 is going to get 1 of 1/4 again. You get 0.25, which is 25%. I mean here 26 divided by 50. Oh, I made a mistake. Anyway, just wanted to show here. The probability getting black card is, let me repeat it, is, so there are 52 cards. Out of 52 cards, there are 26 black cards, right? Almost. So this is half of this. It is actually 1 over 2. And 1 over 2 is 0.5. And that is 50%. Okay, let's go to the next example. So when two coins are tossed, what are the chances that either both hit, either both heads or both tails? So remember when you toss two coins, what are the options? Head, 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 tail, head, tail, and tail, tail. So these are the options, right? So altogether there are four. So this is n of s is 4. And they're asking you both heads or both tails. There are two of them, see? So the event is both heads or both tails. So that's the event. That means when I talk about n of e, number, how many favorable outcomes are there? And you can see oh, this two, so it is 2. So probability of event that when you toss two coins to have either both heads or both tails, it is 2 out of 4, which is half. Okay, and you get the 50%, and you're done. Okay, this is example. In a classroom, there are 13 girls and 15 boys. So let's say this is a classroom, and in this classroom there are 13 girls and there are 15 boys. I don't want to draw the boys and the girls. That's too difficult, right? A class is to elect a president, vice president, and the treasurer. So when you talk about president, vice president, and treasurer, naturally they have those positions first, second, and the third, right? What is the probability if the students were selected at random? All three positions were filled by the boys. That means the first one is a boy, the second one is a boy, the third one also is a boy. And now in this example, this is a problem on permutation. So now comes the challenge. Really, we need to do the hard work. So since we are selecting three positions, right? 1, 2, and 3, that means the R becomes the 3, and the N is the total number of students here. You can see there are here all the students are there are 10, 15 plus 13 is 28. Okay, so there are 28. So let me call the probability since uppercase B. B stands for all boys, right? First one is boy. All three positions are filled by the boys. So we want to know what is the probability that the this can happen is, so you have to have a ratio, right? So the first thing is how many ways can you select these three boys? Now since there are 15 boys, let me this is let's make it nice. Because you have 15 boys, first of all, I would always do the bottom piece, okay, this piece. What this means, all possible outcomes, okay. So that means when you pick from, there are boys 15 and girls, what was it? Yeah, boys 15 and girls 13. These are girls, these are boys. That means if I want to pick three position, 1, 2, and 3, right? Three places, this become permutation. So the order matters here. So the number of ways you can pick this three students is, now these three students could be even boys and it could be girls also. When you pick three, it could be any of this. Okay, so that means there are 28 of them. So this becomes 28 P and 3. Remember NPR, permutation, n factorial and n minus r factorial that we did last time. So that's what the denominator is. Now you put this in the denominator. Numerator is I think I should have written one one. This is the NS. NS means all possible, and N of B means those outcomes that favor all boys. Now, when you talk about the top numerator is all boys, right? Three boys. So this is how many boys are there? There are three boys. So one, two. So the three boys, one, two, and three. These three boys would be because there are 15 boys here. So that is like R. That is like N. And 3R becomes 3 here. So you have to do from 15, you do P, and you pick 3 like this. So on your calculator, you'll be working on this. Remember, if using fundamental principle of counting also, you could do first 15. The next one is could be any of the 14, and the next one will be any of the 13. And you can do this showing all the work, and I'm going to show all the work here. Let me show all the work separately to do this. So first thing is, did you understand this? How to figure out a numerator and the denominator? So let's do only the numerator first. So the numerator will be 15 P3, which is by formula it is 15 factorial divided by 15 minus 3 factorial, and that means it is 15 factorial divided by 15 minus 3 is 12 factorial. And you can reduce that 15 factorial into 15, 14, 13, all the way to 12 factorial, and divide by 12 factorial. You can see this crosses and you get this answer. So this is 15 times 14 times 13. And the denominator is using the same idea here. Because it starts with 28, you do 28 times 27 times 26. Now put in the calculator only the top part, and put in the calculator only the bottom piece, and then use the calculator to find the answer. You should get. So put that in the calculator and you should get, so that means you actually, if you work this out, simplify this, let me show this also. That it means we can use without calculator if they ask you to get in the reduced form. Let's see, can you do directly reducing? We can see 13 divides 16 half, 14 goes half, and 15 and 7, 27 equals 3 divides 5 times, 3 divides uh, 9 times. So you get 5 over 2 times 9, 18, and 2 is 36. And then you use the calculator and you can figure out what is the percentage. I just wanted to show you the different ways to do. Uh, for the exam, what I would say is, if this question was asked, all boys, right? All boys, you will write all boys, and then you write, okay, from this the 28 students, it's like 20, you do 28 P3 first, and the top one is because you are saying all boys, so it means there are 15 boys, and from 15 you pick 3. So this is what is important. If you can understand this, that means you really learned a lot of stuff. Now the calculator does, and I show you how to do the calculator. You find out that first, then you find this, and then you use the calculator and you get the final answer in decimal, 0 point, whatever, blah, blah, blah. Okay, let's go to the next example. So this one is saying a 4-digit PIN number is selected. Now when you talk about 4-digit, when you talk about digit, basically these are the all 10 digit. Even 0 is included here. Okay, so these are 10. And from this 10, you need to have the PIN, right? So these are the 4. What is the probability that there are no digit repeated? It means, that means when first thing is probability. So when you talk about probability, no digit repeated, right? See, I'm just writing no digit repeated. First of all, uh, we have to have it's a ratio of all possible ways of getting this 4 digit, and the uh, top part it says no repetition. That's so how many are without no repetition. So the bottom piece is even repetition is allowed. What that means is you do this, that the first one could be any of this 1, 2, 3, 4, 5, 6, 10. The first one could be any of this 10. Now, or the second one again could have been any of this 10, and so on. So 10 times 10 times 10. So you're going to get 1,000, 10,000. 10,000 will be all possible option to make a 4 pin uh, without, with repetition or without everything, all possible outcome. But especially the ones with no repetition will be different. So this one you can't use anything like permutation combination, just a 10 times 10 times 10 like this. But the top one is no repetition means that there is a permutation. What it means is you are going to have 10 of this, so that n is 10, and there are 4 positions to be filled, so it becomes P and then R. So do you remember this trick? So your answer using the calculator, this will be give you 5040, and the bottom will be 10,000. And if you do the math, you get, of course, 0.5040, which is 50.40%. I hope I'm making sense to you here. So remember, when you talk about probability, it's always the ratio, something down, something up. And the down one, all possible, means even with repetition. That's why I multiply 10, 10, 10. Okay. So the first position could be any of these 4. The second one also could be any of this. So that's what that 10 times 10 times is. So the bottom piece is always all, but the top piece has a condition. That means if you put a number here, any number in the first place, let's see if the first number is 7. Now this 7 cannot be repeated here. So this, so it, of course, it could be any of this 10 of them, right? So the first could be any of this 10. So when you talk about this, basically what this means is it is the first can be any of the 10 position. Once one of them, the 7 is gone here, maybe there will be 9 remaining. See this 9, so this is gone. So this is gone. And then after that, you pick from the remaining 9, you put one more, maybe 5 here, but that could have been any of this 9. So this is gone, so that's how 8 and then 7. Either you use this fundamental counting principle or you do directly 10 before, which we did in the class, and I hope you understood this. This is a beautiful example of lotteries using combinations. So it clearly says you have to use the NCR, right? To calculate the probability of winning a lottery jackpot when 4 numbers are chosen from 1 to 29. So that means, let's see, the numbers are like this: 0, 1, 0, 2, 0, 3, 0, 4. So these are the numbers. Okay, and likewise, they are all together 27, 28, and 29. So these are all together, then the n is 29. I hope that I'm making sense. Now, what are you supposed to do is you have to pick 4 numbers. Okay, the order does not matter. So it means what that means is you have to pick 4 numbers. This is a group of 4 numbers. The first, second, third, and fourth. Now I can pick any of this. I could pick maybe 3, 6, 27, and this could be my my one pick could be 3, 5, sorry 6, and 27, and this is 28. So this could be my. So likewise, our question is, in the lottery selection, the order of the numbers are picked does not matter. So because you are picking just any group of. The question is, what is the probability of winning the lottery? Now remember, so the question is probability of winning the lottery. So let me write winning the lottery, right? So it has to be a ratio, and the ratio has to be numerator denominator, and the bottom piece, remember, it is the n of the event divided by n of s. So the probability, the number of possibilities at the bottom, because there are N is 29. You are picking four of this. R is four. It means from 29, you are picking four. See how beautiful this is? The bottom piece is these are all combination possible to pick four numbers. But the top one, when the result comes, they will always say, hey, these are the four numbers, whatever that is, one, two, three, four. So there's only one option here. That means, and of course, if you win the lottery, let's see, if you are winning the lottery, it has to be one. So there will be only one group, whatever. This is where they pick, four. Now, oh, these are the four numbers they declare. So there will be only one option. Another way to do this also is basically that one is, so from there will be only one option means from four you pick four. That's what means. So if you really evaluate what is 4C4 using calculator is one, and besides that, if you really want to do the actual mathematics, what Prima wants, you can do the calculation. Like what is that means is it is a 4 factorial. Then you have the R is again 4 factorial and 4 minus 4 factorial. So you get 4 factorial, and this is 4 factorial times 0 factorial, and 0 factorial is 1. This crosses out, you get 1 over 1, you get 1. So basically, it's 1 out of the number that you get is here is 23571. So this is 23571. So this number from the calculator will give you this, and that answer is going to be 0.00 0042. So small chances, right? So it's like, wow, this is like 0.0042%. So that's all it is. I hope I'm making sense to you. Let's move on to another one. So if you get confused, we'll see in the classroom. I can explain more better if you get confused with this. So this problem is almost like the same thing. Example number one. So example number 12, we are almost there. In a certain lottery, there are 40. This time instead of 29, we have 20, 48, right? That's the end part. Now, there are numbers 1 through 4 are placed in the machine and 6 are random. That means, let's say this is a machine and it rotates. There are all these 48 balls are put with the number, and this goes round and round, and they pick 6 of these pieces. So they pick 6 of this, right? So one of them will be the winner. Question is, 6 numbers are drawn that match. If the 6 numbers drawn match the number that player had chosen, the player wins the 1 million. In this lottery, the number that are drawn doesn't matter. The order doesn't matter. Compute the probability you win the $1 million. That means that of course when you want to win, you win the lottery. All 6 numbers match. All 6 numbers match. So this is the definition. So probability of all 6 matching is a ratio that there's only one. That means you get out of 6, you get all 6 correct. That's what this means. See? So from 6, you get all 6 correct. But the bottom piece is because there are 48 of them. So from 48, you're selecting 6. Now the calculator does the job. This becomes 1 out of, I think it is. Now, if you use your calculator, this piece, this 48cc, this is going to be 1227152. And put this on the calculator, you'll get 0.23456815. Let me check so to make sure we are correct. 1, 2, 3, 4, 5, 6, 7. So there has to be 7 zeros. So it is 0.1234567 and 815. Okay. So just keep this. That's it. You are done. So very, very slim chances that you are going to win when you pick. It means 1 out of uh, 12 million. See, this is like 12 million combinations are possible when you select a. these six numbers. And I hope that makes sense. What I'm talking about is because the next one is the most important and the last one, and I'm done. Because this video is getting too long, but I feel that I should. I'm just trying to talk to myself. Hopefully it works. So the confusing part is this: that there's only one way you can win the lottery, right? That everybody understands. But what that basically means, you are picking. When you pick six numbers, but your six number, what you had picked six numbers. Remember, you had six, and all six are correct. That's what that C6 means. And the formula is when you have NCN, it's always one. Okay, but if it is NPN, then it is N factorial. This is difference, or uh, you just have N factorial. So just you have to be careful. Now, in the state lottery from the previous example, if five, I want you to underline this. So among this, let's say these are the thing, and you end up getting, let me use a green color to show that, hey, you got all this, let's say this one, two, three, and four, and five. So these numbers you get correct, one, two, three, four, five, but you missed this one. But because you missed means you get $1,000. So the question is asking what is the probability you win second prize? Remember the first prize was one out of there were 48 of them. Okay, and then you got C6, and we remember that was the probability that you are winning the 1 million. But this is probability of winning $1,000. Now be careful. The probability of winning it means probability of getting your five. So when you picked up six numbers from 48, okay, there were 48. One, two, three. There were 48, and when you picked up the six and winning, you win five. You get five numbers match. Five numbers match the out of whatever they said. Match the winning. Okay. So your five numbers are correct. So now you have to have a ratio, right? Remember, I always say it is N of S and N of E. So the bottom piece is all possible. That means there were 48. And you had picked six. So these are all possible. But the top part, there are two parts. That means your five are correct, right? That means from from 48, okay? So from 48, you got five correct. So that means you have to use fundamental principle of counting. What that means is, that means your first step is your five numbers are correct. And the five numbers are correct means this piece, 48C5. Once that is done, but your one of this number, so this one, the green one, these are five numbers correct, right? It means it is 48C5. But then one of the number is wrong. So this one I put a black color, red color. This is wrong. You did not get that one correct. That means out of out of this, see the winning lottery has got six, right? All correct, six of them. That means let me show one more time. I don't know. I just want to talk to myself. I think today it's like one, two, and it goes on till 40, right? So from this, the winning combination is six numbers, right? So non-winning means you got a wrong answer, wrong numbers. So the wrong numbers are, let's say the wrong numbers are from 48 minus 6, there are 42 wrong numbers. So that's the confusing part. So once you're done with five, you got five correct, but you got one wrong, right? Remember I was talking about that thing what I did, the green color. So you got this one correct, these are the five you got correct, but this you did not get this one. So that means you got one wrong out of 42. Remember 48 is all, but six numbers are the correct one. From 48, you take 6, you get 42. So from the 42, you got one wrong. This is the most difficult part to understand, but I hope I'm making sense. And use the calculator. You just put the numerator and the calculator, you get 252. The bottom piece is 1227151 And then use the calculator, you get 1, 2, 3, 4, and I think it is 205. You can confirm this, and we'll check in the classroom if we have a question. I hope I made sense. Now, let me see if there was another example. Let me take this off. And that means there was another prize for getting four correct answers, right? Four correct answers. So if you have four correct, you get $500. So if there was a question, then how do you do probability match, four numbers match, four numbers match? It means the bottom piece will be always all 48 numbers and six you have chosen different ways. But then here, your four match means from 48, you got four correct, but you got two wrong. That means from 42, because so this is the confusing part. See, so how do you get this is the most interesting thing. This is four because you got four correct and you got two wrong. The two wrong is from 42 because from 48, if you subtract 6, because 6 are correct, right? 42 are wrong. So from 42, you have these two. Put on the calculator, you get. And the same thing can be also used if you get three match. So if there are three matching, you'll do the same thing 48C6, but the top one will be 48C3, and from 42, your three are wrong. That's how you do it. Now, this question is a little confusing. An economic quiz contains 10 questions. One, two, three, four. So these are 10 questions with five choices. So A, B, C, D, E. A, B, C, D, E. So each question has got five choices, right? So I'm just writing this just to make sense out of this. Okay, and same thing. Computer probability, they're randomly guessing. So the student just guesses the first question, second question, third question. And he says, okay, he just marks this tick, 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 tick like that. So what are the chances that getting nine correct answer? Now, probability of getting nine correct answer means you get one wrong, right? So this is same as nine correct means you got one wrong. Now, when you say one wrong, basically means so you have to see what are the different ways you can get, what are your possibilities, total number of ways that you can guess. The first one is five, right? And there are 10 questions. So it's going to be 5 times 5 times 5 times. So it is going to be 5 raised to 10 because the first one has five options. So 5 times 5 times 5 times 5 times 5 times. So you do 10 times because there are 10 questions, see? And you got one more 5. So it is 5 raised to 10. The calculator does the job, but the main thing is one wrong question. So this is the how many outcomes are favoring one wrong. Now, since there are 10 questions, it could be any of these 10. See, there are 10 questions. So it could be any of these 10. It could be this wrong, this wrong, this wrong. So so from 10 you have 10 C1. So you have 10 C1. And then after that, let's imagine out of this 10 question, you got the fourth, let's put it like this was the one. I'm just imagining this was the one. But in this case, there are five choices, right? From five choices, there is one correct, but you chose the wrong one. Let's say this was wrong. There are four wrong here. So from four, you select one. Wow, this is so beautiful. If you can understand this, is really nice to know this. So again, I repeat, what does this basically means is out of 10 questions, you got one wrong, right? So one wrong can be any of these 10. That's why it is 10C1. After that, by fundamental principle of counting, then you say, okay, among of this 10, there will be any of these could be this or this or this. So I chose the green one. Now, why did you get wrong? It's because you selected from the four wrong, because maybe E was correct, but you must have done one of these. So that's why it is 4C1. And when you do this little work here, this answer boils down to, oh God, okay, let me write directly then. So it was 5 raised to 10, and here it was you first selected 10C1 and then you selected 4C1. Now 10C1 is 10, and this is 4, and this is 5 raised to 10, 40 out of, and I think it is a big number, 9765, 97. So that's 40, 9765625. Use the calculator. It is 1, 2, 3, 4, 5, and 4. So I hope I made sense to you. Little confusing and makes sense. So you can see this is 14, example number 14. There are 25 parts in which there are 3 defective. So in this case, I make sense there are 3 defective. That means the other ones are nice ones, so green one. The rest of them is from 25 will be 22 will be good one. Okay, that means they are good, non-defective. Okay. Question: if you randomly pick 3 like this, what is the probability that none of them is defective? Now, what is the meaning of none of them is defective? Basically means these are the good ones, right? So the probability of good ones. Now, when you want to select, and probability is the ratio, so the bottom piece denominator is all possible. So how many ways can you select 3 of this? That means you're going to use combination. So from the 25, right? So you can pick 3. That's become all possible outcomes. All possible. But from this possible outcome, you want the top one is how many are favoring your the whatever they ask you defective, right? Non-defective. What is the probability of none of them is? Means good ones. The good ones are 22. So that means from 22, you are picking 3. See, this is how beautiful maths is. If you can understand this, you don't even have to show the steps as long as you. So this one, if you work this out, this will be your 2300, and this is 1540. Put on the calculator, and you get in decimal, you can find out, of course. So that was about this. Now, this is the most easier. I don't know why they gave it so late. So uh, you pick 5 cards, okay, from a deck of cards. These are cards, okay, and there are 52 of them. So that means you're picking 5 cards from 52, right? So when you want to know what is the probability of that exactly one is. Now, what is that meaning of exactly one is? Basically means one is one is, and the other is, and the others are other four are not aces. Now remember the probability is how many different ways can you pick 5 cards? There are 52 cards, right? You can pick any 5 cards. So that's become 52. But the top part is said one is, and there are 4 aces in a deck of cards. So this is ace, right? So that becomes 4C1. But then question is about the other four cards because there have to be five cards, right? So you put C. So one card is already picked up, so your four cards are remaining. And because there are 52 cards and the four cards are aces, the non-aces will be subtract 4, you get 48. So from 48, you take away that. So that means this becomes equals. I know it is a long one. I'm tired. I'm just trying to do this, hopefully. So this becomes 4C1 is 4. Okay. And this one will be, we divide this. And if you work this out together, I think they put on the calculator, you get 778320. And the bottom piece will be 2598960. It's like 259,000. So this is how it works. This is a beautiful question. Actually, I love this question. I hope you understand what I'm doing. The bottom one is all possible ways to pick five cards. The top part you are using fundamental counting principle because there are two steps. The first step is your card is the ace card. So you have four aces and you pick one. Once that is done, your second step is non-aces. So you have 48 non-aces and you pick this.